thank you to everyone for today taking the time to join this webinar, where we will be discussing why choosing between LTE-M and NB-IoT is an urgent matter for global enterprises with our partner Thales. I'm Stephen Osborne. I'm the head of UK, Ireland and Americas, which is one of our 4 defined sales regions within our organization. I'll shortly be handing over to Jelte and Neil to continue this webinar, but before we start, I would just like to take this opportunity to briefly talk about Telenor Connexion. Having pioneered M2M communications in the 90s, Telenor's first large-scale partnership came in 2003 with Volvo and Verisure. As M2M continued to grow, Telenor recognized the need to have a dedicated IoT-focused company and founded Connexion in 2008. In 2008, we've grown our offices from Sweden to incorporate 10 additional offices situated in UK, Germany, Italy, the US, South Africa, Singapore, Japan, China, Malaysia, and South Korea. We at Connexion enable and empower new and existing IoT customer journeys, aiming to create long-term partnerships with a consultative approach to truly understand and deliver upon our customers' total solution requirements and needs to deploy and manage their solutions and products globally. We do this today via our one offering, incorporating one contract, relationship, invoice, point of support, and roadmap for managed IoT connectivity and cloud service offerings, which can be complemented by many other solution enhancements and service excellence tools available over 180 countries and in excess of 400 operators. Telenor is positioned as a leader in the Gartner Magic Quadrant, and Berg Insight has ranked us in the top 3 IoT operators in Europe and top 10 globally. We have deployments across all verticals and dedicated segment managers who possess expertise in their respective areas, including automotive, smart meters and utilities, transport and logistics, and industrial manufacturing. Connexion has had a physical presence in the UK since 2010, and today have a full sales, account development, technical team supporting our growing customer base and assets. If you would like to know more about Connexion and how we can help you in your journey, please feel free to contact me or one of the team. If you have any questions during this webinar, please feel free to share in the questions section. I'll now hand over to Neil Bosworth from Product Marketing for the Thales IoT division to continue the presentation. Thank you.
Thank you, Stephen. And I must say, to start with, I'm very pleased to be taking part in this webinar today. So I'd just like to say very quickly, say a few words about Thales. I work for Thales, and we've been making IoT modules for years, beginning with the world's first automotive GSM module. And the automotive quality assurance philosophy has been richly ingrained in our DNA throughout our existence. I think using our unrivaled experience with combining processing capability, eSIMs, security, technology, together with cellular IoT devices, we've continued to connect industrial applications with trusted communications for 25 years, just about, from the original M2M, when it was called machine-to-machine communications, to the complex systems we call today IoT. In terms of cellular communications and available standards, where are we today and what's the outlook? Well, 2G and 3G, along with their adaptations for higher speed data such as Edge and HSPA, with technologies really specifically designed for people and cell phones. The pioneers of IoT, as I said earlier, used to be called M2M, designed systems to use this infrastructure, starting with standard simple modem functionality. Then they incorporated internet protocols, and they also took advantage of SMS. But these networks were never really designed for machines. Moreover, the clever people at the start of the journey adapted the features of something that was designed for phones to apply them to machines and things that we call now called things, of course. With LTE, we saw the first divergence with a cellular technology specifically designed for the consideration of the demands of remote devices or things. And LTE Category 1 was the first standard ever specifically targeted for machines, and it's still very popular today. And it is in fact a throttled version of the Cat 3 or Category 4 that you get on your mobile phone today. The benefit is it's supported in every country in the world with a standard implementation, and this kind of adds longevity and stability to global deployments. And then we come to LTE-M, and I'll use Cat-M and LTE-M interchangeably. I'm sorry about that, but that's just the way it is. LTE-M and narrowband IoT are the world's first 3GPP technologies designed for low power, low complexity, and the low cost aspects for IoT for remote devices, which will be taken forward into 5G. In 5G, we see more adapted standards better fitting to the use cases, and LTE, Category M, and narrowband IoT will form the MMTC use cases for massive deployment. And MMTC stands for Massive Machine Type Communication. So if you're coming from a design which may have used 2G or 3G, what are the differences between these new MTC technologies? Well, firstly, I guess is probably transparent to most people, but the system bandwidth, as well as lower energy across a narrow spectrum, the new technologies are quite flexible. But Category M or LTE-M is like LTE Lite. There's a lot fewer differences to move forward. Narrowband has the ability to fit in different areas of the spectrum, which makes it probably maybe more flexible going forward. But today, Category M is the easier technology to adopt. But look at the data rate. For those who migrate from 3G with TCP/IP connections or large file transfers, they really need to consider the data rate. Narrowband IoT is designed for tiny data transfers. It's designed to send small amounts of data from a sensor. I'll talk about latency and coverage more on the next slide, but there are some differences, as you can see. Latency is normally not an issue for IoT devices unless you really need real-time communications. However, mobility often is, and narrowband IoT is designed for simple fixed applications. There's no cell handover. You need to remain in the same cell for any form of mobility, unless you can tolerate a switching off and a network re-registration. Voice is something which appears in quite a few IoT applications: alarm panels, lone worker protection systems, etc. Category M's got a roadmap to cover simple voice coverage. One of the main objectives of MTC communications was to keep a device running for 10 years on a single cell. Again, advanced low power design techniques are essential to make this happen. It doesn't work just out of the box. It's worth saying that antennas, Category 1 should use 2 antennas, but it's not normally the case, even though officially it is. The exceptions almost become the rule now. The new technologies are designed to be simple, so they just use 1. But when you can see that you really need to consider the application and look at these variances before choosing a technology. I mentioned that I'll talk about latency and coverage. These are important new features to consider. In order to keep the power consumption to a minimum, the paging cycles are extended, and the application can be tuned to really extend the paging cycles and to actually turn off the receiver in between the paging cycles. And this is known as EDRX, or Enhanced Discontinuous Reception Mode. But essentially, latency can be traded for or compromised for their power consumption. Traditionally, to get the lowest possible power in a device, the designer just simply turned the module off when there was no data to be sent. This is fine, and it's still an acceptable technique, but when you turn the module back on again, the network needs to be scanned and the re-registration process needs to take place, and this all takes power, and it takes rather a lot of power. In power saving mode, the module can be put to sleep, and the network essentially remembers its existence. It remembers its identity, and therefore when you turn the module back on, there's no need to do the rescanning again. And this can be a considerable amount of time that you can turn the module off for, up to 3/4 of an hour, maybe with Category M. For deep indoor coverage, Cellular has been questioned in the past, especially at the high frequencies with a low power radio. Enhanced coverage mode effectively keeps repeating the same message. It keeps hammering the same message until the receiver has received the entire packet, giving the receiver a better chance to reconstruct the message. But all these features are there to save power, and they're optional and they're configurable. That is, it's in the design of your system designers to decide whether they need them or not. However, there's some things to look out for. Different network operators may apply different rules for these features. In some cases, the network operator may ask the application not to use the feature, such as power saving mode and extended discontinuous reception mode. For SMSs, Category M is supported, while as narrowband IoT is not always supported, not yet. And this might seem like an old technology, but GSMA standards use this technology for SIM configuration, etc. Coverage enhancement, well, some operators have a limit, for example, on the amount of repetitions that you're allowed to use. And finally, some operators may have requirements about the actual size of the amount of data bursts that you can send, and that's kind of important if you're sending firmware updates. Incremental firmware is essential. This is a picture of LTE coverage in Italy, and the UK is much the same, to be honest. And you can go to the GSMA website and you'll find these maps, but you'll never find a fine-grained map of the coverage locations which have narrowband IoT and Category M. Not yet. Often claims are made about 97% coverage across a country, which is probably okay for phones, but the 97% often covers the population and not the geography, and we quite often put our devices in remote locations. So rural areas may not have the coverage for Category M or narrowband IoT, which means you need a backup plan. And the backup plan today is often to use our good old 2G. And if your devices are planned for roaming overseas, then 2G makes quite a good insurance policy for now. But be careful, 2G doesn't have these nice power saving features that LTE-M and narrowband IoT have. So you have to bear that in mind. As a module manufacturer, we see a lot of interest in these new technologies. Initially in the US, where 2G and 3G was axed and CDNA was very quickly replaced by LTE a few years ago. LTE-M was the first network deployed in the US, and this happened a couple of years ago. But different countries have different rollout plans for the two technologies. Narrowband IoT has mass adoption in China, whereas in Japan, one of the major operators in Japan decided to halt their narrowband IoT deployment and commit only to Category M. In our range of modules, we need to be as flexible as possible to cover the planet with the right network technology for the right geography and the right application. So we need to have Category M modules only, narrowband only modules, modules which contain both technologies, and others which contain both technologies and 2G, and we have to squeeze these into the smallest package we can. We also need to cover strategies for over-the-air firmware updates, which include incremental firmware over-the-air updates. As I mentioned before, the size of the data may be limited by a network operator, and an easy-to-use firmware over-the-air campaign platform. We can embed the SIM inside the module and add additional functionality features for security. We're preloading certificates inside the module, so identity certificates, to make it easy for cloud onboarding. But fundamentally, we're ready with a wide range of modules and services to help your next IoT design across these NTC technologies. And that's me about the devices. I'll now hand over to Jelte, who's the product manager at IoT at Telenor Connexion, who'll give you the view from the network operator and from Telenor Connexion's global perspective. Thank you. Over to you, Jelte.
Thank you very much, Neil, and good morning, everybody. I will now have a look at the LTE-M and narrowband IoT from a global perspective, also from a rollout perspective. As Neil has said, that we now have technologies out there that are not just made for the Internet of Humans, let's say phones, etc., but are dedicated and smarter, made for the Internet of Things. Both LTE-M and narrowband IoT have these functions to have a long battery life and a better indoor coverage. And it's made for the Internet of Things and smarter. And it is introduced during 4G, so it's actually a 4G technology. But during the 5G life cycle, these technologies will be available. And there are some other 5G enhancements like enhanced mobile broadband and critical communication, which we will not discuss today. So why is this an urgent matter? This is an urgent matter because operators are looking at replacing 2G and 3G technologies with more up-to-date technologies. And we see, especially in the United States, as also Neil said, that the amount of 2G networks is disappearing. Actually, not much 2G left in the United States. And also we see that in parts of Asia. In Europe, we expect that 2G networks will be available for at least 5 years, but perhaps even longer, because 2G is still used for many applications. For example, emergency calling in cars, but also it's being used for a lot of telemetrics devices. The 3G, however, will disappear more quickly in Europe, while the 3G will be more available in other places in the world. Of course, in other sessions, we can dive more into detail in each country. But here is just to make sure that you understand that 2G and 3G technology, we need to move towards 5G. What is the best technology? And there often LTE-M and narrowband IoT are good candidates. But what is the best technology? Narrowband IoT and LTE-M are a little bit overlapping when it comes to things you can do with it. But what is the best technology depends on the use case. And our use case is that we have a single component, let's say a single subscription, a single SIM card or a soldered SIM card or a UICC, and that you are deploying in one of our networks. So it's like 400 networks, 180 countries with all these different technologies, where you then have one point of contact. So for this kind of use case, so you have one point of contact, one integration, or one managed connectivity. For these use cases, LTE-M is the better technology than narrowband IoT, and we'll explain you why. First of all, the LTE-M is roaming agreements are moving further ahead than narrowband IoT. And that is because narrowband IoT has been deployed by operators often as a local technology. For example, we have narrowband IoT and Telenor networks in Norway and in Denmark and in Finland, and there we target a local market for static devices, whereas mobility is not part of this. So mobility and roaming comes as an afterthought. LTE-M is just another variant of LTE. Therefore, operators are more looking of also expanding this to global possibilities to allow inbound and outbound roaming. We see also recently new LTE-M networks have been deployed. The United Kingdom have now a LTE-M network deployed, and also in Germany there are now 2 LTE-M networks. Deutsche Telekom has deployed a nationwide in Germany. And narrowband IoT in Japan, one of the operators there has shut down and urges customers to focus on LTE-M instead. And why is that happening? Can be, we believe, very much a combination of business case for the operator, but also technology. This is the current state of the LTE-M roaming that we are having. So at the moment, it is 6 countries where we have LTE-M roaming agreements signed, and that is of course in the Nordics, but also the Netherlands and the United States. Then you see on this map many yellow countries. There are LTE-M networks deployed by our roaming partners, and we have existing roaming agreements, but we have not done all the formalities and all the testing and made a commercial 100% agreement on the connectivity there. But devices can already today be tested in those networks. The power saving mode and the extended coverage might not be working yet. Now, the ambition of Telenor Connexion is to rapidly expand this roaming network to come to the same level as our current LTE network. And that, of course, will take time. This is bilateral agreements, but right now we're already starting with those 6. Why is LTE-M more important? It's a technical aspect, and the narrowband IoT has very low latency and a very high latency and a limited bandwidth. That means that if you do something, it is actually rather slow before you get an answer. And if you are looking to do your connectivity to reduce cost, for example, predictive maintenance, what is the reason why you are connecting your devices? Is that to reduce the cost so you can do proactive maintenance? Then this narrowband IoT domain can actually add some value. But if you want to grow into new use cases, you would, for example, like users to remotely control their devices more than just sending a little bit data, then LTE-M is a better suited technology. LTE-M can grow into new business models because it can support human interaction, not just for consumers, but also, for example, for operators. Just imagine you are operating a specific industrial valve or like a switch. You press a button in your screen and you expect this valve to actually close quite quickly. It's not relevant for all IoT use cases, but for many, it is better to have a low latency and a very predictive latency. So LTE-M allows you to grow. And also LTE-M allows better firmware updates. And why are firmware updates relevant? There are 2 reasons. First of all, everybody today wants to be quickly go to market, right? The software industry is already completely working like this. Software updates are rolling out all of the time, even for cars, for example. Why is that happening? That's because we constantly test new pieces of functionality with users and quickly adapt the user experience. Now, the traditional hardware industry perhaps is not there yet, but it's slowly moving to that direction. So if you as a company are thinking about slowly moving to a more agile way of deploying, then you need to choose the technology that is ready to support you with that. Also, if you think about security, if you think about secure design, you have to think about an update strategy. You might, as a network engineer, perhaps do the calculation on just sending a little bit data and think, okay, we think about those software updates later. That really can be a problem with narrowband IoT. That's what we have seen. Let's take this very concrete. And what does it mean? Actually, Neil showed already some numbers there. I show you some mathematics which you can do by yourself as well. We talk here about a theoretical maximum speed. That is a speed you actually hardly ever will reach. But I mean, the design, right? LTE Cat M1 is designed for 1 megabit per second, and LTE Cat narrowband 1 for 26 kilobit per second. So what does it mean? Well, there are 2 use cases. If I send just a little bit data, let's say a kilobyte, both technologies work very fine. There's no problem with narrowband IoT. It's actually very well suitable to send small amounts of data. So it works very well. But if I send a picture, for example, I have a picture I want to send for 1.5 megabyte, it takes 3 minutes to upload that one and 12 seconds in LTE-M. You also then see that LTE-M is not for your streaming video, right? But it's good, for example, to send a small picture. If I download firmware and I have 1 megabyte of firmware, it takes 5 minutes minimum and 8 seconds minimum in LTE-M. Now I checked one of the devices there. I saw it had a 3 megabyte download to do a firmware update. If that you have to do, it will take 15 minutes per device. That's a lot of time, and it's much faster in LTE-M. Of course, this is especially a problem when you have a fleet of devices. It's easier, therefore, also if you are on 2G, 3G, and you think we need to look at new technology, look first at LTE-M because it feels like 2G, 3G. It has all the characteristics like the mobility and the latency. It's made for the internet age, work with software updates. It also works with SMS, for example. We have SIM swap, the EU ICC. Perhaps you have heard about that, to swap the profile on a SIM card without changing the SIM card itself. Yeah. that is easy with LTE-M because it needs an SMS support. The narrowband IoT is when you have to be extremely efficient and really would like to have the maximum out of your battery. It comes with a price, with a reduced user experience, and you need to have a careful design around that. We believe that LTE-M will be driven by these replacements a lot. So therefore, we believe that LTE-M is the first choice for global deployments. Narrowband IoT is very suitable for local deployments, very simple data, but for our customers, we from Telenor Connexion think the global LTE-M subscription is a much better choice to go for the LTE-M. Now you need not only a good subscription, but what you also need is, of course, is good devices. And perhaps Neil, you can talk a little bit about the different devices that you have from Thales to offer.
Thank you, Jelte. Yes. So for Europe and the UK, of course, that's the same thing. We are launching devices that support the 3 technologies in one package. We think that's important. And of course, these come in different form factors. The black box here you see is surely the simplest way to evaluate LTE category M or narrowband today. It's a simple plug and play device, and you can use this as a final product if you wish. But you could also use it to very quickly evaluate a product in the field. We of course have development kits, but you could use this black box as a rugged development kit if you like. Contained within the black box are modules. We have different modules. They're either category M and narrowband, or category M alone, or narrowband alone, or in this case we have category M, narrowband, and 2G. So you're pretty much assured a connection anywhere you go in the UK if you use one of these devices.
Yes, yeah. Thank you, Jelte and Neil, for that today, and all those who joined today's webinar. I hope everyone found this very interesting and informative. If you have any questions, please feel free to reach out to any members of the team, and have a good day. Thank you.